Oh no, was it too loud? Sorry. Now there is sound. Is it too loud? It feels like it's blasting your ears. We get it a little bit down. How about now? Okay. That was a little bit, yeah. I moved the capsule to another recorder, to an audio recorder. Now it's pointing in the wrong direction. Okay, here we are. Oh, did you see the goal by Democratic Republic of Congo against Portugal? I love good underdog stories. This is one. Hey TMK. That was cool. That was now it's halftime. Hey Sonic. Halftime, and today I had like 3 naps. I had like a sequence of naps in the afternoon. Recently, I'm struggling with back pain, and I don't know what to do about that. And since totally not interesting, yeah, I know most of you are not into football, but once in a while, every 4 years, especially since Tony is also enjoying it, I watch a little at least. So I'm struggling with back pain recently, and I was sick on the weekend already. And yesterday I finally caved and took an ibuprofen 600 and give us pink labs. Oh, right. Not that. No, this is the one. It's not even focusing because the So yeah, I took an ibuprofen 600, and basically I was never a fan Kirschkernkissen to warm it up. Yeah, that might be also a good thing to try. So what? It's too much. Yeah, let's focus like that. All right. And what and massage, yeah. The ibuprofen releases some, like, not only removes the pain, but it also reduces inflammation. And what happened is, since yesterday, I don't have any back pain anymore. So usually it lasts only, like, the pain relief only lasts for up to 6 hours. Ibuprofen 600 is like more like that, but I didn't have the 400 at home. That's why 600. The 600 are still left from my knee surgery. I don't know how long it is ago. 8 years ago, 9 years ago. So they're quite old, but yeah, I rarely take meds. But it seems like basically having the pain, everything is tightened up in my back, and the back pain is like everything. If it's inflamed, it's basically everything is like tightened up in my back, and it just gets worse. And since yesterday, I had a relief with that. I don't want to get addicted to. You can't get addicted to ibuprofen, but you can basically harm your digestive system or like your stomach with too many meds. That's why I try to not take too many. But I'm really relieved since yesterday, and I was able to sleep really well tonight, and have a few naps today, which is good. And the question, Zokrif LP, this thing is a computation cluster, but so far we are not really using it to compute anything because um, because cheers, new booster, fresh booster today. Here it is. Because we didn't have time to finish stuff, and I need to release a video, and the video will be about the hardware design and manufacturing and whatnot. That's why I just need to show a demo, and this is the demo. Hey, lines and squares. And last time we were able to improve the speed. Hey, Holy Flame. Last time we were able to improve the speed at what we are transmitting by a factor of 4. So we are 4 times faster now, but it's still only like 8 frames per second or something. And what I would like to do is I would try to, now we are at the limits of what basically the SPI is capable of. So SPI has also some limitations. We are at 7.5 megabits is the SPI limit at the lowest level. We are not using the 16-bit bus yet. That would take a lot of time to solve, so I don't want to touch that today. I just want to increase the frame rate and make like some demo, put some demo on that, just to like transfer, to show something in the video that looks nice. And yeah, Boost, it's really ice cold. I don't know, our fridge started like to really refrigerate today. I had to turn it down a notch, but it's good for the booster because it's really cold. Yeah, so let me show you let's take paint. Take paint and let's see what we can do today. So basically currently we have the USB, that's USB to level 4, which is connected to two MCUs L3, and then we have 8 MCUs at L2, which are basically the blades. So we have like, and the blades have one MCU, that's L2, and then we have 16 L1s, and then we have 32 L0. zeros. Currently, we are sending, okay, this is, with this MCU, theoretical limit is 12 mbit, but we can only achieve, as it seems, only 8 mbit here. Oops. Oh, come on. Boop, boop, boop. Let's do it like that. 8 mbit. Hey, Foo! Thank you for the boost. Okay, so we have 8, 8, oh. You can't see. I need to zoom. There is no zoom in between. 8 mbit here, which is currently the limit, but yeah, 5 levels in total. Let me show you the replacement. We noticed that this is the V303, and if we replace it by 307, we get full speed USB with 480 mbit, which is way faster around. So that will improve in future, like this level. But also we have like 2 bus options. The stable alternative here is like, currently we are running it at 7, oops. Think it, no, wait, we running at 44, I think it's also 8, ow, 8, what is it, what's wrong with my mouse? Also 8 megabits. We can run it higher speed. We can try to run it at a higher speed. That's only the SPI, and then we have like the option to for 16-bit parallel bus that we don't touch today, but basically, and then we have also the same here, 8, and the last one is 7.5 currently, unless we like levels 1 to level 0 or 7 point, but the bandwidth splits like every junction here. So basically this is the bottleneck right now. Currently I think it might be this, because we can still try to get a higher clock rate on that. I didn't use the highest clock there. We can try another speed. And what I would like to do, since it's easy to upload this firmware, so update this firmware, and this firmware, it's only 3 nodes that we need to update to, and maybe these here, that's another 16. What? It froze the video. What? So hardware revision to Ethernet. This here is completely this section. Ah, the animation. This here is completely replaceable for revision 2 and so on. This is a V1. This is the baseboard, which is the round shape where all the blades are plugged in. If you look at this device, the round 60 centimeter diameter, no, it's 50. It's 40. Is it 48? 50 centimeters diameter, something like that. In the PCB, that is that can be replaced for only a minuscule fee of 400 euros. We can get a new one. Boop. Mini blade, which this part, no, like in the this one, no, not happening. No, I not paused it. The problem is I switched windows, and since it's controlled by the browser, as soon as I hide the window, the browser window, it's basically paused. Yeah, I don't know. I probably could use a task or whatever. What is well, what is the interface? Okay, I'm yeah, worker thread. Oh, look at that. So there might be an update coming in quite quickly, because yeah, blah blah blah. It should arrive at 16th, but we have now June 17th. It's in transit, but custom clearance leaving origin country arrived at the local airport. Package left airport. I don't know if it is. This is like. Let me check that. That probably it's not trackable by 17 track. We can try 17 track. We might get like the full speed, high speed MCU replacement quite quickly, and L4. Yes, yes, basically yes. I can show you where we have even, I made it more or less modular, because I added like pins to the bus. So we can access this complete, here, this section, here, this bus here. There is a 2mm pin header that we can basically intercept. So we could like plug a card in here, bloop, with something else on, like, I don't know. But there is still like this bus is still, I mean, physically the limit. What we can, if you think about this, like if we use the 16-bit bus here, the theoretical limit, 16-bit. What is going on with my mouse? Yeah. If we use that, and let me think, what would be the clock rate that we can achieve there? Looney Express, yeah. If we clock it with 10 megabits, 8 megahertz, which is realistic, because we can write with one cycle, we can write the complete 16-bit. I put it on one register. Let me show this. Let me start Altium here. I can show you that. So basically, we can use at least 8 times 16 is 128 megabits per second here. If we can achieve 16 megahertz, then it will be, and double data rate, if you will, then we can go as fast as half a gigabit on that bus here, which is this right? Actually, yes. Yeah, it sounds a lot. It's not a lot. Half a gigabit is not. No, it's not. Namaste. 1.21 gigahertz. Yeah. We can test that. Okay, wait. A stick figure. I was still recording. What's going on? Wait a second. Why is my workspace not connected? Okay, yeah, whatever. I have a local copy. Let me open. That's not that. Okay, here. Here. Yeah, this is the bus. We have the two chip selects. We have MISO, MOSI, SDK ground, blah blah blah, and then we have the 16 bus lanes, and these are this is the USB connection here basically. This is USB. I tried to put like a ground here, but this doesn't look like very balanced, so we will probably not get high-speed USB here. Also, I mean, this is not really, I didn't put much attention into making that bus. Look how long it is. This is like half a meter of trace here. And then, oh, you got ice cream? I will also get ice cream. So this is the bus going in. Alright, wait. You can barely see because it's going on an inner layer. Which layer is it? It's on the back layer here. Oh yeah. Oh yeah. Look at that star formation. So it's not really great. I will probably bounce here. Bounce. So we have like the 16-bit bus, and then it's connected. This is the level. This is level 4. This is level 3, and this is also level 3. And then we have this is the bus going around to the blades. So look how I put some attention into having ground everywhere, like in between the traces, so I really don't get any crosstalk and whatsoever. So strip line, waveguide, whatever you like, it is. Yeah, so that's the blade right now, and we could connect something else if level 4 isn't sufficient for our needs. So we could just put something in here and disconnect that, just remove it, heat up, and or remove just power or whatever. Then it would be even closer, connect closer to that if we have like an edge card that fits 2 millimeters. I don't know. We could probably even just solder sorta the edge of a PCB to like top and the bottom to these pins here, like really weirdly. Or we put pin headers and then just put the PCB in between the pin headers here. That feels like it's a perfect 50 ohms impedance matched. Oh, here is, oh, there is a ground missing. Anyways. This is so. Yeah, as it works right now, thank you, Chris. The sheepo, I almost missed you. Hello. We were talking about a topic that would be of interest to the sheepo last time. The sheepo, when you left, I forgot what we are talking about. We're talking about certainly about 80s animes from the 80s, but was there something else, another topic? I forgot. Gunbuster, not Gun Blaster. That's older than you. 80s. Gunbuster. You know some animes from that time, do you? Like, Manga Entertainment, the distributor, the British, Australian, whatever. I just learned that Crunchyroll is basically Manga Entertainment renamed. So when it was like bought by some other media company, I only started when selling it. It's same for me. I watched Mila Superstar. I don't think it was Sony. So I my first animes were like on Sailor Moon basically. That ran even on public the public TV, like not in Captain Future. Maya, yes, that was even in Poland. I watched Maya every Sunday in Poland when I was a kid. We even had in the 80s. In the 80s, we only started in Poland with a black and white TV, and we had like the color TV later on. So I remember the time where we had black and white TV and then got a color TV in the 80s. Imagine that. Crazy. Yeah. Maya was the first one. Then are we dating? What? Oh no, I can't remember any of those. No, I was like more than Tele 5 in Germany, which had like plenty of the 80s anime series, quite old ones. Hey Quinn, you got a mention in my latest video that I'm editing right now. I had to thank you about like helping me with AllNet. Gigi the football player. Yeah, that was Kick-Ass and Superstars. They're like two anime series with football, and there was like one anime series with the gymnasts. Yeah, but the real deal were the serious grown-up animes that I started watching in the 90s by Manga Entertainment. Basically, if you watched the intro from Manga Entertainment, like I paused it and checked every single anime that was shown in that intro by Manga Entertainment, I wanted to watch each of those movies, and that were like, of course, Akira, Project Echo was one. I found a source for Project Echo recently. Uh, then we had Pet Labor. That's on my list. Next one, but I watched it quite a long time ago. It was in the 90s. You haven't seen Akira? What? Oh, that's so influential. That's cyberpunk deluxe. You should. Yeah, that's that. Um, Now that we are completely sidetracked already. Oh, it seemed boring. No, it wasn't boring. It was like it was very serious. It felt like the that was at that time. I mean, when um, I was a teen. Oh yeah, Chris. Oh, how old have you been at that? What age did you watch? What I found uh, traumatizing. I don't want to spoil anything, but basically what happened to Kaori was like the most traumatizing thing for me when I watched Akira for the first time. I still remember, so you know that was really sad because she was like always so supportive of Tsubasa. No, Tsubasa. Sorry, not. What was the name? Kaneda was the one with the motorcycle. What was the name of the one who escalated? 14, yeah, right. Nate, yeah. I watched it later. I wasn't. It wasn't in '88 when I watched it for the first time. Um, Maya the Bee was very sad. What happened there? Oh, I'm sweating. Why am I sweating? Yeah, this thing. You wouldn't think, but I calculated the maximum power that it can pull up to 80 amps. This thing, this setup there. It's not right now. I actually don't know how much it's pulling. We can calculate. Let's calculate. I think it's like 15 watts per blade right now times 16 divided by 3.3. Yeah, 72 amps. Willie died? What? Are you kidding me? No! No, 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 no. No. Willy is the other bee, the drone. They even toned down Captain Future quite a lot. Yeah. Guccio. As who is dying at Binemaya? Okay, then that might be sad. All right. I give up. I give up. So yeah, that's that. I finished the last book, but from the Red Rising series, and it's not completed. I'm so angry because the author took like a cheaped out with like the last antagonist, or let's say one of the antagonist characters just like escaped or whatever. So basically gave an option for the next book. So it's just another book that I have like to wait for 1 year probably before it's released from now. In German, probably even longer if I want to listen to that in German. Oh, this is annoying because I mean they could just end the story already. I don't want to spoil things, but yeah, it's now. He can always. Yeah, I think there might be even a prequel. There was a prequel release to Red Rising, but let me check. I have like this is on Audible. I even like the last two books were split into two. I mean they were long enough for like what is it 20 hour per book, but recently added. Okay, I will show you. So I finished like 6 books now, and it's still like open how it ends. At this point, they could really like just end it. The last two were just split into two parts, but each book is what is it? No, stop! Don't download it. Yeah, 20 hours. Yeah. Sorry. Distraction. Yeah. Sorry. Kaspa. Let's go. Yeah, so plan for today would be since we are sending 8. No, I'm not remaking, Natsu, not remaking it. We are just optimizing the protocol. What we have like bottlenecks, temporary bottlenecks until I receive like this MCU, which will be in a few days, but like a replacement for that can be reworked easily because I used low temp soda paste. We can just heat up the base. I hope I won't melt it though. Shit. Yeah, I need to remove quite a lot of stuff here. Yeah, but I will be able to rework that, which is quite cool. Replace it to get like full speed USB here. I mean high speed USB, and this can be upgraded. But what we are doing now is we are sending with full speed USB each packet bulk data is 64 bytes. That's what we found out last time. 64 bytes. Maybe I can start record bytes. Oh, we can have Ethernet right now. And this MCU is actually capable of doing Ethernet, but we are using the pins. What I could do is I could hook up to this thing like the dev port that I got of the CH32V417, which has USB 3 with Ethernet and everything on board. So that's just a dev port. I just need like to connect it with pins. That could be easy, but I need to now then to start like coding that and whatnot. So that's quite a lot of effort. Let's just postpone that. What I can do for now, we are sending like we improved last time to send like packets. We are each packet for each LED or for each MCU with new RGB data like RG. Oh, this is now tooth. Oops. Let's make it thinner. Like set RGB RGB is 8 bytes. So we have 8 packets packed into, yeah, this is like 8 bytes. What we can do, we can organize the data in a different way, where we basically, we tell, instead of having like wasted 5 bytes for addressing and everything in that packet, we just send the RGB value, like an RGB value for not a for half a row or something. So we can update twice as many LEDs with the full 64 bytes. We would need like to change how we communicate on these levels here, so between L4, L3 and probably L2 if we want to chroma subsampling. No, chroma sub. Yeah, we could go down to like 15-bit or whatever. I'm not sure. We can. The easiest would be like to send double the data, like densely packed. Let's say we address half a line, because more than on 64 bytes it's a little awkward. We can only, what is DSC? DSC, oh, yeah, I don't know. We can just ask. We can just ask Gemini to quick ESC stream compression method in C. Okay, here we go. Look, standard compliant codec in there. Quick! Oh, you didn't. Wait, you can see it. This is the irony. Like it's sarcastic. Look at that. Look at that. In a quick snippet. Oh, this is. Is this? This is the first time. This is the first time I see Gemini being sarcastic here. You see concept decode. Okay, it's a concept. Residual. Quantized. What is this? Baseline initial prediction midpoint. What? It doesn't like a concept, okay. Predict next pixel value based on the previous one, encoding only standardized residual. Compress the stream. Here is a lightweight, high performance stream encoder decoder implementation in C. Okay. Median adaptive, feedback loop, quant shit, okay, whatever. It's funny. Yeah, quite lightweight. Wasn't there like open source AI getting bolder and bolder? Yeah, this is scary. Yeah, what we can basically do. Okay, what I wanted to show is if we calculate, like we have Currently, we're limited to packets of the size. We can change. We can make longer packets with high-speed USB. We determined it was like what is high-speed USB was 512 or 124 bytes per packet, which would be more convenient. But 64, if we like do 24 bits per color, if we divide it by 3, we only get 21, which will be basically 20 pixels, which is not a full row. We have 32 pixels per row. And this will be awkward like to decode, because then what we can do here, basically we send like a chunk of pixels in one packet that's 64 bytes. We can send it here and either decode it here and split it into individual packets with generated addresses for the individual MCUs that are controlling the pixels, or even here. So we have even more bandwidth on layer 4 to 3. But if we only doubling the speed, as you can see, usually we can pack 8 pixels into one chunk, and if we do, let's say, half a row, 16 pixels, which would be alright with the addressing, it would be simple. So 16 would be, instead of 8 pixels, we would double it to 16 pixels per 64 byte packet. So actually we are fast enough on the bus wouldn't be a bottleneck anymore. Since we are sending to this one, this will generate the blocks and send it here. It might be better, but it's way more work to reprogram 16 of the blades. Instead, we can try to implement a version that's only decoding here. How about that? Someone's writing me stuff. Okay. Hey, people are contacting me always. Hey Tommy, how are you doing? Yeah, so we can try doing that. That would be easy. Almost showed my stuff here. Testing it on this board here. We have like a one with the USB. We can implement that and test it basically later. What is go? Did my screen die? What happened? Huh? So weird, my screen bugged out. Not yours too. No, I don't know, it bugged out for a second. Did I touch anything there? Is it a HDMI cable loose or something? This screen that bugged out is really old. That's a Flatron, an LG Flatron IPS 23.5, which I bought when I started YouTube 12 years ago. Probably even older, like 15 years. Let me check the build date. They both, the displays both work, only they physically like the stand broke or whatever, so they are wibbly wobbly but still working. Let me check build state. AI state, yeah. The cluster. Huh. Can I see the... Where's the build date? Oh, 2012 build date, August 2012. So now it's 14 years old. So there you go. And both screens work. They had like a discoloration because there was like some, I don't know, weird, like between the layers. I had already, it's so weird. I had like, I don't know, it's maybe dust or whatever in between the layers, so there are like a slight discoloration, but it still works. 12 layers, yeah. They're quite complicated. They have a thick frame. You know what? Which one I like? So I had a bank in the meantime for my HDR. I had for coloring and calibrated a calibrated screen from BenQ or Bank, or how do you call it? Bank. Which cost me like $500 back then, and it melted the last time last year. It melted for some reason, I don't know. It started to heat up in one corner and destroyed itself. Yeah, if you start like that to hide the area. Too high dynamic range. That was the dynamic range went into infrared in that case. Yeah, really like it radiated on the next level, and I didn't have a lot of money at the time where it broke down, because I'm always on the verge to being broke. I'm always spending every dime that I have. And I bought this Lenovo screen, which is quite good. It's not like ultra great. It's not like OLED or anything, but I like the quality of that so far, and how it behaves. Is not perfectly calibrated. It's HDR. What is the screen details? Dell. Depends. You can get like crap from Dell. I have like I don't like my Dell laptop. They cheaped out. The screen is alright, but like the other stuff, nah, they didn't do a great job. Yeah, totally. You can get cheap crap with like really big gaps between the pixels. Yeah, 55. I think that my next one will be also an OLED. There is no excuse anymore. They're like way cheaper than professional screens. Yeah, just buying an OLED TV is way. And also my eyes got so bad last year. I had like perfect sight, and all of the sudden my eyes are like, I don't know, not great anymore, and I need everything in big font. So I have like to put the 55. It only gets worse. Yeah. I need 55-inch screen, OLED screen in front of my face now. This will be next one. with the sugar level down. I'm not having any sugar. Your company made a deal? Okay, let me check. Let me check my screen details, which screen it is. Oh, what? You're diabetic? Type 2? That's not great. Yeah, you Dutch people, you like you eat too many of the hagelslag. Dude, you need to stop eating like the sprinkles for breakfast. The grote noten or hagelslag. Okay, so this screen. Yeah, retinopathy. That's not great because, like, if you have too high sugar levels, they will form crystals in your bloodstream, and that will hurt your retina basically. So you get permanent damage, and you can see it from the through your eye on your retina. You can basically see the damaged regions on your. That's not really good. Yeah. Yeah, I had like a girlfriend for 6 years who had type 1 diabetes, so I know all the details about diabetes and what the consequences are. You should really be careful with your sugar levels. Do you have like any like aid, like a measuring sensor, a permanent one, and the insulin pump to regulate it? Before architecture. Yeah, we are discussing improving the speed for now to double the frame rate and do something so with. But I wanted to. Yeah, it was sidetracked again for that screen. Where's the details? All right. Yeah, you need like to stop drinking like those really sugar reactive, like the sugary drinks or orange juice is terrible for that. Anything that has fructose. Oh yeah. Do you want to see? I will show you my screen setup. That's basically for editing. I removed one screen from my setup because it was like I noticed I'm never using it. Here, this is my screen setup. That's why. So this screen on the bottom here, that's like the smallest widescreen that you can get, and I 3D printed a stand, and this is basically a full screen timeline when I'm editing. So this is the setup, and on the top there is like this is the HDR screen for full screen HDR view of what I'm editing, and this is basically the screen when I'm editing. It has like all the assets and everything. So I pull in the assets into the timeline and watch like in full like UHD, HDR. This is my editing stuff. Yeah, and this is the screen is N27p, quite cheap and a good quality. Can we check how expensive it is? This is by the way. This is by the way the thing. Going. Where is it? Let's check. And 27p. I still have the stickers since my lower screen is just in front of the frame of the upper screen. I still have the stickers with all the advertisement details of that screen. Lenovo. Yeah, that's not expensive. I got it, I think, from how much is it? 27 inch. But it's 27 inches too small pixels for me, at least for on UHD already. You can't get this product anymore. What? Okay. And it has a cool stand. Yeah, 300 bucks. Roundabout, yeah. It's way cheaper than the BenQ. You can get it for 200. eBay used, okay, yeah. Think Vision free. Notebooks billiger. Is it used? Yes, that's true. Energy stuff, blah 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 blah. Yeah, 200 bucks. You can get this screen for. But this is not the same. This is not our stand, is it? Yeah, whatever. Anyways, let's get back to our coding session. Boop. Bucks, dude, euro. Yeah. We can do what we can do is basically we can try process USB buffers. Oh, that's unobtainium. You can't get this anymore. This is like this because I wanted one that is actually I got it used. This I don't know how much. Yeah, let me. Oh, I hope I don't disconnect it by accident. UM5. I can't. UM58. UM58. Is it UM58? Oh, maybe I have information here in the menu. No. UM58. Okay. Let me check. Nobody would buy such a small screen. What is it? 22 inch? No. No, that's not the one that I'm looking at. That's like a really small screen. It's just really wide. 102 NTWG 25521. No, that's the serial number. Manufacturer. Product code. Model number 25UM58. 25UM58. Maybe it's 25UM58. cheapest ultra wide monitor. uh, 25-inch. Is it 25-inch though? It doesn't look like it's 25-inch. It's very, very small, yeah, but it might be that one. No, that's not that. No, 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 it's IPS. I think it's IPS. Yeah, I think I made sure that I get IPS. I bought once, I got a TN screen. I sent it back the same day. I just turned it on, then turned it off, put it back in the box, and yeah, forget it. It doesn't matter. It looks so terrible. I don't know how people, they probably sell the TN screens to like kids or whatever with, oh, I have a new gaming computer. I never had another computer in my life. That's why I don't know what I'm looking at. It's so cool. I got like 120 frames per second. But it's TN. Like, it looks gross. Like, it changes color if you just turn your head sideways. Something like that. I don't know. Esports, yeah, because they're quick. Yeah, I don't know. Oh, are they? Are they people who are using like super fast CRT screens? CRT might be even faster, aren't they? Like you can have like 100 hertz. I know, I remember the time where CRT screens were like 100 hertz or something, or 90 hertz. I remember the time where you had a CRT screen with two DVI ports for half the. No, that wasn't CRT. Was it? What? One of the last Windows also made it ready for one kilohertz. 120 hertz neck. Oh yes. I need that. Let's ask fastest CRT. Yama Vision Master Pro 512. Record 700. This is this is the resolution I'm aiming for. 320 by 200 allows for stable 500 hertz. Oh yeah, wait, that's holy grace. That's yes. Yombo, that's my name. The pinnacle of CRT, 130, 42, like really odd numbers. Natively low resolutions. Better motion clarity than more than 360 hertz LCD. Instantaneous response time, yeah. It's crazy. Wait. Can we get one of those screens off eBay? Or I don't know, this would be so crazy. $160. Okay, let me try to get. Yeah, that's. Ah, no, there were videos. If there are videos, then it's basically mehr erfahren. Ach, Scheißdreck. 3,000 euros? What? Yeah, that's a collector's item now. GTX 180 Ti DisplayPort. Starting. Oh, damn it. Here you go. Crazy. Oh, he's looking for one. Yeah, you probably won't get one. Let me try to get 20. Yeah. Vision Master. You probably can't get them. No. Vision Master. Shitty beamer. Nobody will sell it because like. Oh, look at that. No, that's FB flyback. Huh? That's a completely different screen. That's like a different screen. This is wow. The collector screens are really expensive. Damn. Oh, okay. Same flyback. Vision Pro. Let's look for that. Yeah. That's an unfortunate, but I have to live with what I have here. Yeah, we can buy a necklace, my friends. We can buy a necklace. Okay, the buffers. We had SPI packet size. We can just increase that to a higher byte count. That's the data in packets. USB buffers. That's the USB buffers. Buffer size is I think that's endpoint. That's the 64. So what we can do, we can try to decode it and just update, generate the packets here, and then when we're sure that works, we can upload it to the first level. When we are sure that works, hey Pat, we are trying to improve the frame rate on this device here. Yeah. Yeah, but we are like for 1 hour we are just sidetracked with every other topic on the planet here. Um, CDC data received. We have the decoding is use 1 as the extra byte to receive a message correctly. Hey, this is working. Hey, we vibe coded this in the browser, so the Julia animation set is it's all transmitted over serial to the device from the browser. We are only using browser nowadays for mockups or a quick demo or whatever. Way easier than anything else. Yeah, of course. It's Julia 4D Julia set animation. It's just scanning through a Julia set in the third dimension. Also, we could rotate. Hey, thanks for the follow. Rotate around like the third and fourth dimension. You never see anything more permanent. Yeah. That's what we try to change. Higher frame rate and make it like uh, float or whatever. Okay, wait. We should be, or maybe, you know what? We can do a little bit of fun coding here and change the animation to something different, like wibbly wobbly water wobbly thing here. So if we map that's map XY, that's Z, that's L0, L1. Yes, webhelp, here we are. Yeah, it's a little bit messy here, but we are mapping X, Y. We should be mapping function map XYZ to L to cluster, whatever. It should return this will be basically L0, L1, L2, L3, and that's X, Y, Z, and we will get the closest. So we need like a mapping. Let's get like that. So currently we have we have the array is can't even draw a straight line. Circular array like that is star formation 16 blades. Paint needs the dark theme. Can you switch it? I mean, it's classy to use like the light theme. So we have that. This is the array. We have X, Y, Z. That's X. That's Y. that's Z. So we map a different way. We need, first of all, oh, the origin should be here. So let's make put the origin here. What we need right now is A10 for this angle here, because we need to split this by 16. So we use A10 too. So we use const a math A10 and it really doesn't matter if we if it's x or y, if we flip x and y. It's just y and x think A10 then we have, that's the angle. The angle is in radians, so we divide that let's call it blade. Pick the blade here. Gears rotating in my brain? Yes, so that's what's happening right now. It isn't relevant if it's like slightly rotated. It's something is x and y. Yeah, I know 2 pi, but I think we can immediately use L2 here by multiplying it by 16. No, it's not, because we have like no. Okay, we need to call it blade here. Blade, multiply and divide by math pi times 2. Okay, that would be the blade number. Then we need to split the blade. Oh yeah, we do math round. No, math floor, which would be trunk. No, floor. We need an integer number because we don't want to round up. We always round down. So we have between 0 and 15. In that case, const L3 will be like which half of the, here, if you look at that, we have 8 blades here and 8 blades here, and they are basically oriented like that. So L3 is like we have on this level, you can see L3, we have only 2 sections here. Is basically blade boop boop and divided by 8, which is that. This will also, using shift, will also give us like an integer number. So L3 is alright. No, this is L, yeah, and also L2. Const L2 is basically blade and 7. Easy peasy. Then we need L0 and L1 is basically that. That will be a little bit more difficult, because in that case, no, we need only Pythagoras. And we need to decide what scale, what is the radius of this whole thing. Do we use like 0 to 1, like from -1 to minus, like radius of 1? Let's do 1. Okay, so we use that. I learned it really late, but this way of mapping a return value, I just learned like recently, like last year or year before, I don't know. And then we need xy is a different axis. This is the axis on the mapping on the blade. We figured that out. And it's starting at the bottom or the top. I don't know. I don't really know. Basically, it's z divided by... Yes, that's really cool, huh? That's one advantage of JS. So we use also radius of one. Z is 0, 1. Okay. So basically, y will be x is math square root of, can we calculate length? I don't think we can do that. That will be basically x times x plus y times y. That's basically what we get. The interesting part is we have a gap in the center that's not mapped at all, because our blades, we can calculate that. There is like a blind spot in the center. We should measure that. I think I have it. Wait, we have a mapping here. We can calculate that. It might be if I display the layer. I display the layer, we can basically see what is the actual distance of the blade. Or I did it here. I think I made it here. We can actually see here. This is the mapping of the blades if it would be a full array. And what is the measurement? I think this one here. This is more or less, it's just, okay, distance is 137 of the last one will be round about here. 137. Okay, so 137 divided by, what was it, 239. That's our blind spot. So 0.57 is our blind spot here. 0.57. So (5.7) on V1. It's basically where nothing is displayed. Okay, so the radius but how do we map it if it's, oh, we can return basically, oh no, we need to reverse return it. We need to map from not from the coordinate, but we need to map the other way around. The blade pixel, this is wrong. This is if you want to map a volume to the, oh no. Oh no, okay, yeah. We need to calculate the other way around as well. Okay. Do I have a function that does the opposite of that? I hope I don't think so. Because if we want like to map each individual LED, it would be easier to start from the LED, not try to map something to the LEDs. This is if we will like track an object and try to display, like if it's flying around like a void or whatever, then we get the pixel address from this function. But we want the other way around. We want to map the pixel address to the point in the space, so we can basically calculate whatever function we are calculating there. So I need to reverse it, but I will complete this whole thing here. This will be weird because we can't map that. Okay, so const d is basically, this is the distance minus 0.57 times 16 divided by 0.43 times 16, because it's 16 pixel. That's if d is or d is greater than 15, return, no, just return undefined, whatever. In that case, also if z is or z is greater equals 1, return nothing. So we basically made that. I need a different function. Function map cluster to XYZ. And this will be different. So what I get is L0, L1, L3, L2, L3, L3. And the first layers will be easy. So X and Y is easy. X math, we can take sin. Let's get the angle first. Angle is basically math pi times L3 plus L2 times math pi divided by 8. So this is the angle. In radians, then we just do angle times this will be hard. Wait, yeah, 543 times 0.43 divided by 16. Hold on, didn't it lose information on the part where it can't get an integer? In this function, yes, your stream is a little bit delayed. Yeah, this basically rounds, like truncates to the next closest LED, basically. But we can ignore that. This is like, we really need this function. This is way more interesting because we can map that to basically the Julia set. Currently we are just mapping the Julia set around like the cluster. But if we want like actually the physical coordinates, if we want to map that to the pixels, we take the pixel address and then map it into the physical space, which more or less is represented here. So this is divided, times that, and this is basically, we need the LED column like that, which will be weird because the column, this calculation will be complicated. We need to reverse our mapping. We can test that. We can test that. Plus 0.53. That's what we map physically. There is no scale, it's mapped to like normal space. So radius 1 and height 1, and then we have const z is basically rho times basically rho divided by 32. Rho by 32. That's z, and the y is easy peasy. Y is cosine. So this is basically const r. This is our radius. And what we are missing is the only a row, only a row and column. How do we calculate that? We have r theta. That's yeah, but not if we want to map it to like whatever you like. I mean, I map it is theta. In that case, this is A is your theta. Where is it? A is your theta, and R is this. This is your R theta dimensions. We are just converting it to XYZ for mapping it to Julia to basically like whatever we do in 3D space. We could do like another level of calculation here to convert it from R theta to XYZ. Anyways, let's I don't know what you want right now. Elaborate, please. The pixel index. Now we had. This is the calculation. Let's see. Because we can use that. We need to revert that. Okay, so L0, Y and 1. Okay, there is a Y and 1 times 16. Okay, that's the column. So it is probably, since the port sits on the other side, we probably need to do something different here. So it's probably 15 minus x and minus L0 and 15 this is probably it. Column and a row is basically depends on how we reverse it. That's L1. Yeah, we can do times 2 plus L0 4, but this will be minus 1 minus that on L0. It's probably something like that. We would need to check that. We will just draw something to the screen. This is weird. Okay. You know what? We will do switch a 1. Okay, 0. Oh. Okay, 0. Yeah, let's put bracket around that. Is this correct? Yeah, looks alright. And let's just do. We can do another level so it's clear which one it is. Now this is we're doing the reverse now. We don't need to map like to the closest pixel. We are mapping the pixel to basically the space, because it's easier to iterate through all the LEDs and the addresses because they are integer, and then map them to space, whatever I like to display there. System! What? We have Tommy and System at the same time in one stream. 2 people from Iran. Yes, we managed to do it. Tommy, if you're probably seeing on the chat from YouTube, that's cross posted here. You can see both people from Iran that we have, System and Tommy. Amazing. You survived, yeah. You probably, System, I was not worried about you because you're living in a like rather not like populated region, more like in the countryside. Wait, did I invert it? What did I do? Here we go. That's so cool. Farsi mode. Double brackets. Yeah, it's it should be only one. We have people from Iran. Peeps. That's so amazing. Vodowiesel. Hello, by the way. No need. It was hell. What, really? Oh, I know. Oh shit, you're living close to the sea. Oh, I didn't think about that. Are you safe? Is your family well? I hope so. You missed YouTube? Oh wow. So you're basically living at the street of Hormuz, don't you? That's like really close. I mean, everything. Oh, no, not street Hormuz, but you live next to the Caspian Sea, other side. Okay, all right. It's all right then. You're not captured then, or whatever. No drone boats or anything. Saw Trump at G7 before, but didn't get it. What happened? They bombed there. What? Is there like, I don't know, are there any facilities there, or was it just really random? I don't want really to go too deep in that. Oh, the port. Did you record it on your phone? The port. Oh man, this is crazy. It's so depressing. That's why Iranian Navy. Yeah, alright. It's really a depressing topic. That's why I don't want to go too deep into that. But I'm really happy to see that you both are well and your families. Not safe to record. Oh, I see. So basically, you don't want to risk anything. You sampled it. The Sound of War. This is the new band, or it's the track name. Oh man, this is crazy. I'm sweating really. I'm really emotional about that. I'm happy that you're well, and there is some sort of peace for now. You never know. I mean, with the crazy people, but you don't see other people's chat, by the way. You see on the screen, don't you? Oh wait, you have like a very low resolution. Here we can see there is Tommy. Tommy is the other person on Twitch. So we have we have the two Iranian people on Twitch and YouTube simultaneously, and the only thing is my on-screen 160p doesn't cut it in resolution. I'm sorry. Tabriz. Okay, let's look it up. Maps. I don't want to expose anyone, so Tabriz. Okay. Tabriz. Okay, Tabriz is here. Ah. You know what? It's not that far from. It's not that far from system. System is from, as far as I remember, round about here, isn't it? Like here? Is it here? Yeah, I remembered. You see here. And that was like, this port was bombed. Damn it. That's heavy. Let's see. So is this like destroyed now, or what happened here? Were there like ships in this port here? Oh, this is the Navy. I see that. Look at that. There's like corvette and... Oh no. Oh, look at that. That's the one with the helicopter landing place. And that like storm ships, storm boats. And these are the private boats or fisher boats. They probably got hit as well. Damn. So sad. Whew, yeah, so you are like... Yeah, damn it. Yeah, this will be like, once the update on Google Maps is, it's probably everything is destroyed. So you're actually here, Zali. All right, yeah. And Tommy is Tabriz here. It's not that. Is it far? How far is it from Tabriz to the blue roofs? Real-time service. What? The blue roofs. Oh, all that hungers, all that industrial area is. This is like, but that looks like it's more like of, I don't know, like trading goods. Not it doesn't look like military. Yeah, these are like. This is like for transporting coal or probably like grain. Look at that. That looks like grain to me. Doesn't it look like grain? Completely eradicated. Yeah, this is the military. Okay, I guess you get like, okay, this is the shipyard. You can see this is Navy. But this is like trade here. Okay, you get some. This is oil. Yeah, but this is like typical shipping containers. There was some sort of fuel. Did it burn? Like, did you see dark, like big clouds and columns of burning fuel here? It's weird. It looks like there was like a new. Is this destroyed or rebuilt? Because these are finished. These are like open, and these here look like. Oh, artillery. That's military goods. All right. Yeah, frustrating. But I'm really happy that you both are well. White explosions. Oh damn, that's crazy. Yeah, I'm sweating just talking about it. It's all about like ambitious of some crazy people. Nothing else. So let's talk about math. Your second war. Uh, Let me think. What was the first one? Iraq. Oh, 82. Yeah, okay. I didn't get that. So, was it like Saddam Hussein was supported by USA to fight against Iran? What were the circumstances? Yep, exactly. Yeah. So CIA supported basically. Wasn't it like CIA wanted a regime change in Iran, so they supported Saddam Hussein to fight Iran. Regime change. It wasn't a regime. They wanted like to basically switch the government in Iran to basically support their interests, and then they supported Saddam Hussein, and then they fought against Saddam Hussein in Iraq later on. George Bush Senior, BP, was it B? Oh damn it. Okay, yeah, land grab. Okay, I have no clue what I'm talking about. It's like history. If yeah, if you like you could basically spend months of reading Wikipedia on all those conflicts and who was involved, and it's so crazy. Let's do math. Yeah, let's go on. Okay, we have switch one. So this is mapping. We have Julia set. We don't map that. Target. We can map int iteration to rainbow. We can maybe use that. Target address. Iteration to rainbow. We have, this is the address. Let's get, oh, is there, no, we map exact address. Map address to pixel index. No, map cluster. Yeah, it's so crazy. So we have L0, L1, L2, L3. That's our cost X, Y, Z. Do we return it also? Or are we just calculating it? No, we're not returning anything. Almost missed that one. X, Y, Z. Yeah. So now what we want to do is basically x, y, we will do const r equals x divided plus 1, because it's from -1, mapped from -1 to 1, divided by 2, hey ITT, times 255, because it's 1 is the maximum. G is basically y, and B, and that should be just a cube, a RGB cube. That will be z, and we don't need to do anything about z because this is between 0 and 1. Okay, payload, map, blah blah blah, Mr. Freeman. Don't need to map any, why is it? Oh no, wait a second, what is this? This is no good. This is no good. L0, this is, yeah, this is not great. 32 and L0, 16, L1. No, it's not. Where is it? It's const. What are you looking at? No. It's here. What? No. What? No, it's not global. This is just RGB in like R like red. We don't map here anything. Target address. Oh, where's payload? Oh no! Payload. Ah shit. No, payload is basically this. Why is it? Why is that? Target address. Blah blah blah. It's R. Yeah, it's so const is basically like a const whatever. Let is a local, and var is global. And we have BS16. That's payload, and 67 is just a dummy byte at the end for more or less like. Yes, var is basically global. I didn't know, or wait, not really. That's var is like if you don't anything, it's really global, but it's like scope. We can let's educate. Everything with AI now. Educate me on let const var. Okay, breakdown. Var the old way. Okay, before 2015, I didn't even know. That's why I was confused when all of the sudden let shown up. So scope function scoped. Okay. Function scoped. Reassignment, redeclaration. Hoisting were hoisted to top of their scope and initialized with undefined. Okay, the modern variable, sorry. Okay, yeah, that was function scoped. Okay, if declared in the function, it belongs to the function. If declared outside, it becomes global. Okay, so that's that. But if and for loops and everything is ignored. So if you have like a var inside of a for loop, it's still valid outside the for loop. Unlike local variables that are scoped within C or whatever, a block. And let fixes the scoping issues. So anything like curly braces would finish this, like enclose the scope. Hoisting are hoisted but not initialized. Temporal dead zone. That sounds weird. It's just like let I have no clue. Initialized as accessed early. Okay. Throws arrow. Hoisted. Oh, that means yeah, you don't. That was held back because of the word. No, it's not my doubt. Hoisted were like, what does it mean? It's basically forward declared. Like if you're using it, how I understand it, if you're using it before it was declared, it causes an error. Yeah, var is initialized as undefined until it's actually defined. It's weird. I don't know what hoisted. Hoisted, yes. I have no clue. Hoist. Okay, yeah, whatever. Alright, we have it here. Everything is nice and dandy. 2015. I'm a Gen Z in JavaScript. Not Batman. This is that. We can test that. Should we test it? It should. Let's turn it on. Let's turn it on. Let's see what we want to see here. We should be able to connect it, start animation, nothing. It's broken. Okay, what's the error? Undefined now. Content unavailable. What's the error? It's something is broken. What is something's not right. We are missing stuff. We are probably a switch case. Wait, this is weird. Where is this function? No, it didn't say anything. This is weird. Okay. Wait, where's the switch belongs to that. So we need to push everything one more. Like that. Close it here. That's weird. Oh no. We have too many closing. Oh yeah, and we need the break here. Break and break. Yeah, that's the problem. Yeah, double case 0. But where is, wait, this is the scope, there is no scope here. Okay, here we go. That's correct. Okay, now let's start. You found the arrow. I'm not great here. Ah 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 oh. Still, I can't see anything. Okay, let's see if we are even entering this. Yes, we are. Okay, what's the payload? Yeah, it's mini. Yes, wagon loads. Okay, what's going on here? L3. Is everything alright here? Target address. I need to see what we calculated. Payload. Payload should be show hexa. Can we display it in hex, please? Oh, yeah, look at that. The numbers RGB. Well, we need to clamp them. That's not good because in that case we probably messing with our check here. So RGB XYZ, yeah, in that case math floor, or do we floor it? Yes, floor. Or is it 256 in that case then? Let's be cocky and see. We might get errors, but if we no, nothing. Okay, let me check. Yeah. Okay. 0, 0, 0. Okay, that's the first one. But why is it all zeros? Huh? Oh, no. Yeah, sorry. We need to floor it from here. Ah! What did I do? Yeah, we before I floor it, we need to do it like here. We are flooring it before we scale it. Yeah, but this still doesn't explain why we don't see any updates on the actual array, though. Something's still off here. So target address payload, it must be something wrong with the payload, though. I need, let's watch. Let's add watch payload 24. 103 is this 67? 103 is 67, is it? Can somebody check if 103 is 67? Okay. So that is correct. Okay. It's counting up. It's counting up all the LEDs. Huh? I have no clue why that doesn't work. That should be really working now. Huh? There's nothing in the console. Oh! It worked! It worked! Huh? It just needed a weird restart or what? Okay. I have no clue if the mapping is working or not. Okay, I see. There is the blue in Y direction, that works. I have no clue if that works. I'm terrible at colors. I don't know if it's scaling between green and red. Oh no. Oh no. I have no clue. Does it do? What does it do? It's smooth, yeah. Log scale, yeah. We. It's so weird. Okay. Should I move the camera slightly so you can see better? Huh? It's way too bright for the camera. Either I need to scale down. Not all the blades, it's only 16 blades so far. So I can, but okay. Okay, let's start. Peeps, let's start with only one color at a time, okay? So let's do R, basically. Yes, it's 16 blades, it's only 8,192, 92, or, yeah, let me connect again, because it looks like, I don't know what's, oh, look at that, we lose packets. Okay, where is the lowest red value? That's everything is Okay, the lowest red looks like it's there 16. You're probably not seeing one because it's you're looking straight at it in the back. Right here. Yeah, it's way too bright. We need to scale down the brightness. Let me do that. Let's say 64 for now. That was lost packets. We are losing packets probably on the USB when we send too fast. Yes, we will get a new base later. Currently we are only no, we have bandwidth, but this I'm not seeing any changes. Should be darker now. I have no clue what's going on actually. Are we losing packets? Okay, let me reconnect so we don't have like Windows Risk V edition. Okay, this is in the initialized state. Now we are reconnecting and starting. It's still so bright. Now it's sending that stuff like that. Let's do like times 16. That is weird because that's quite bright. Okay, the lowest value seems to be on the right side here. This blade has the lowest X value. Oh yes, we have 0 here. You can't see, but on this blade, basically this corner is 0. Yeah, here's 0. Here's 1. So this is the bright side. This is x0. This is x1, or this is x minus 1. This is x1. So if we do, that was x, if we do y, should be similar. So let's do also only 16 colors on that. And then we have here. If you look at that, we have 0 here. There are these LEDs are all off. So because we scaled it only to 15, and there is positive. So we have. Let me do that. I need. The only thing that I need to check is if we got X and Green Lantern. I have no clue. I can't see the difference like in the back if there is like if it's increasing in brightness or if it's reversed in that case. Max, that doesn't do shit. The brightness of the LEDs only pull like 3 milliamps and the MCU pulls like 8 or 10. So it's minuscule. The LEDs don't do much. We have 8,000 LEDs. It's like on max brightness it's only like 20 amps. Web UI, yeah, that's what we are doing right now. This is our test software. How much RAM did one have? 12 kilobytes of SRAM. I didn't. Tommy, don't be so pushy. The packet loss is just between the USB and the SPI. Either we increase the speed of the SPI, lower the speed of the USB, but we will replace the chip of the USB, the level 4 chip anyways. What we can do right now is we could try to increase the SPI speed and hope that it won't cause any errors because it's between like the CH32V3 and which one? You're always so negative, dude. Okay, we have X X0, X1, or this is -1, and this is Y. Okay, if we map like that, this is our coordinate system. I have a coordinate system like that. Now we need to check. I don't know yet if it looks like it's correct though, because we map we need to map gamma. Let's improve on gamma. This is cocky prompting. Give me JS gamma. Log gamma LUT. Here is the gamma LUT. That's amazing. Apply gamma correction. This is actually what we want. This is the LUT. If we want a lookup table. So basically we take that as the function. Okay, thanks, bye. Okay, thanks, bye. Here we go. Oh no! Oh no, I wasted power. Catch ya later. Let me know when you're ready. Good. Okay, let's do gamma here. Function gamma. turn, and this will be C. But we could also do basically map from I don't have a checksum. I have only like the check byte 67. If that is correct, then the packet is aligned. This is not really important. I mean, if we get a fast update rate on that array, then if we miss like 1 pixel, next frame it will arrive. I don't care. It's like, I don't want to waste too much time if it's only like for visualization yet. Okay, if we are doing that, we could also min max and then math floor it here, floor gamma map 255. Gamma value is here. Gamma, okay. So what we do is now, yeah, it does need to gamma map, you're right. We do it here. Blah 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 is basically not, we don't need the floor anymore, and we don't need that. This is, yeah, this is the gamma map, and what we need is like gamma of 2, gamma map 255, and that's basically it. This will be our new function. We don't need that. Need that. Whoop. Yeah, that didn't work. It's all black. Wait, what did I do wrong? Echo mode. Yeah, echo mode activated. Yeah, no, we don't input 255s. We do that, okay. We input between 0 and 1 and then map to still not. I don't trust it too much, because we had like the restart blocks. Nah, it doesn't look like it's working. Okay, let me check. Oh, we got an error or what? What was that? It was just showing crap. Okay. Let's check G. Looks correct. Yeah, this looks alright. Port close, yeah. Here we go, alright. Yeah, we have some gamma. Actually some gamma. This is actually 0, and this is really bright. Oh yeah. Yeah, that looks like XY really. Okay, now let's try red. This is getting bright in the back. That's cool. I love it. Okay, gamma mapping is nice. Now let's do yeah, it looks really nice, like the smoothness. If you would watch, I don't want like to destroy it, but if you see like here, this would be 0, and then we have like a physical mapping of the coordinate. So the next ones, this is like 1 or whatever, value of 1, and then it's increasing. There's one dead pixel. Ow! Where but I leave it here because that's y. Let's try x again. And gamma map that. We can do even like higher gamma value if we want to. Okay, let's do that and try again with 0. But I think we got an error in y direction because it's weird with the order of nah. So, why is it? I don't feel like it's probably some weird stuff going on. Do I really need to like reset the USB or what's going on? It's really weird. Okay. Yeah, now this is the dark side here, and this is the bright side. You can't see it. It looks like on camera it looks way. Reset USB. Oh yes, you go to the shell and type reboot. Yes, this will be a calculation cluster. We can mine bitcoins, render ray tracing graphics. It's a graphics card. Okay, let's do more like a DIY graphics card. We will have a VGA port in the end, so okay, let's test. This thing has only 8,192 cores. And extra 256 floating point cores. Like the good ones. It's not many. Why is it refusing my connection? Please. What's going on? It's somehow either, I don't know, it's resetting or can't see. Yes, it's way more expensive than anything. The current price would be 10K. I guess like when we have the 32,000 cores, it will be performing a little bit better. Oh no, come on. $13K? What? This is crazy. We can build an ultra cluster for that, but it doesn't have that much RAM. I don't get this. I don't know, packets. It's like misaligned packets. I guess it's misaligned packets. Let me reset completely. RTX 590. Nah. Let's sponsor, let JC sponsor the next spin of blades. Okay, peeps, that doesn't look great. What did I miss here? Gamma map Z. Everything is increasing in price. Yeah. My new script, I'm challenging the NVIDIA CEO. Loving the black LEDs, really bright. Robert, that's good. Was kaperst du? No, wait. Yeah. Ah, all right. Okay. And black LEDs are really. That's you got me. No, it can't. It can't compete with a single RTX 1050 or something. I don't know. I don't know how many. They're running at so high clock speeds. I couldn't compete with that. And also, we are missing a lot of bandwidth here. So that will be rather. We will see in the end. I have no clue. Yeah, if we count like let's say I have the full build, which has in the end what is the 16 times 128. Okay, we will have 2000 FPU cores in the end that are running at 144 megahertz. So that's the theoretical. I don't know how many cycles they need to calculate, let's say, a multiplication or division. Not sure. We would need to check then the RISC-V implementation of that, because the FPU on the V303 is not like super standard. It's like I think logarithmic math. Yeah. So the actual capabilities there will be, yes. The floating point cores, the integer cores are running at 100 megahertz. They can, however, I managed to increase the clock speed of those on my other project where I was generating a TV signal to 120, stable 120 megahertz. Probably 140 is also possible with good cooling and slightly higher voltage, which we can do. We can we can generate up to 4 volts here. So yeah, this is still all right. It's 56. Yeah, that's 45 degrees C. Overvolting. Yeah, you need, otherwise it won't be stable. At some point you need higher voltage or lower voltage. I have no clue. The issue is I think they need more current at least. They are running at a higher current. Not sure if what happens there. Okay. Theoretical floating point cap at 144 megahertz. Let's say we use 1 clock cycle multiplication, which is you certainly need like 2 or 3 or whatever. So that would be 300 gigaflops. That's not much. Like if it was 1 clock cycle multiplication, it would be 300 gigaflops. With only the floating point cores. Yeah, CUDA card? Okay. Your CUDA card was probably a little bit cheaper than that. But this is only like level 1. If we can emulate if we can emulate okay, let's ask a Gemini. We have a good instruction set on, we can do a square root reciprocal in probably like 30 cycles. Okay, what is the instruction? Okay, how many cycles to do one 32-bit float multiplication on RISC V with bit operation extension but no FPU. I did actually completely enclose all signal lines between 2 ground layers, so I have no radiation whatsoever except for the crystals that are exposed. So everything here is vibrating with slight 32 megahertz. This whole room is vibrating because we have like plenty of cores that are vibrating right now. 8,000 crystals. Blah blah blah. Yeah, this is the counting the zeros. Okay, we have 40 to 50 clock cycles. Okay, let's be conservative. That's what I thought. One cycle. So we can calculate 6 layers. We have, let's say we have like this build version 1 has 8192. They can do basically 2 megahertz FPU. So it's basically times 2 megahertz FPU, because it can do 200 megahertz for 50 clocks per multiplication, which is basically 2 megahertz FPUs. Yeah, this This version has 16 gigaflops on just this version here, and then the full version will be 16 8 times that, so times 8, 131 gigaflops on top of that, which is not a lot actually. Yeah, this ultra cluster sucks, but it's very fast with integer operations. It can do iterations really great. Yeah, let me calculate again. So 6 times 2 millions. No, it's 131 gigaflops. So actually the row controllers are way faster than decimal points. 32-bit floating points or integers. If you want like doubles, that would probably half the speed. There is probably a hack to be faster. What about fast R scored? Because that I used that for my array marcher on this cluster here, and I know that's a little bit faster because there you can calculate many calculations at the same time. So a fast square root reciprocal would be 160 cycles. No, that's the float. Nah, that's not correct. Float multiplications, because you don't do the multiplications, you do integer operations. Here, count zeros, 20 to 30 cycles total. So if you do square root reciprocal cycles, yes, basically. If we can do 100 million cycles per counting leading zeros. This is one key point why I picked this MCU, because it has bit operations and it counts leading zeros, and counting leading zeros is important to calculate the exponent of for the floating point. So you have like a conversion to floating point, then you have like the bit operations for this fast square root reciprocal. If you don't know what I'm talking about, I will show you. That's the Quake trapezoidal. Tommy, don't show off. Here, this is the calculation. It's basically when you're calculating length of an vector, you have like you want 1 divided by square root of something. If you have like the length, you will add like do the square of x, y, z, add them, and then basically pull the square root of that and divide like the length or of one axis or whatever. You need always like the reciprocal of that square root to multiply, to normalize vectors for example. And you need this at least once every pixel if you calculate colors and normals, and every reflection, every collision in ray tracing you need square root reciprocal, and that's usually done in graphics card. You have like lookup tables for square roots like that, and they do an approximation, a wrong cutter, or like an iterative model here. This is basically the same. It's using you need the second iteration usually for it not to look weird. So second iteration actually is necessary in my opinion, but this is like yeah, some added complexity here. So if we can do this stuff, float, look accurate, what? But if we do multiplications here, we need to, okay, we have like the mantissa, we multiply the mantissa, we can, that's like fixed point with, we need to add the exponents. So the multiplication here, if we decompose the floating point values into like mantissa and exponent, that's actually fast. We just need to add add the exponents here, and here the minus is basically a mantissa. Yeah, you need to do the shift probably. Not sure about this. I would need to check my implementation of that. At what precision? Yeah, you will get like a precision of probably 12 bit mantissa with the first iteration. Second iteration give you more. Yeah, this is the second iteration is really needed. I tested this. I don't know if I have footage of that for my rematcher, and basically anything like the first iteration is really, if you have flat angles and like everything looks really janky. You need the second iteration if you want like to implement reflections. In Quake probably there were no reflections. You had only like, you calculated only light vectors. They were alright. I mean it was some garage shading. Yeah, wiggling. It's not the polygons. It is more of the lighting. The lighting on the basically on the vertices were affected by this, and then the normal or whatever was maybe interpolated. In the best case, the normal was interpolated. Otherwise, it only like I don't know, the garage shading. Only the shading value would be interpolated. Anyways, if this can be done in 30 cycles, then it will be way more than 130. Just log too easy. Mon, hello. Yeah. Okay, why don't we see anything here? I want to see why we don't see anything here. We need to check what is going on. We are wasting time. So many people are heute online. Yes, today online. Online today. I need to learn English eventually. Blah blah blah, Mr. Freeman. Here we go. That's that. Why? Why? Oh, not a number. What? Why is this not a number? Huh? What? Oh, I'm missing the 2 here. Yeah, that's why. Oh no. Yeah, here we go. Hmm. Is it incrementing properly? Yeah, only twice before, yeah. That's okay, let's do gamma of 1. No, 1.5, okay? Yeah. Come on. Ah. No, it's not updating. I don't know what. We have like misaligned. We have misaligned packets, I believe. Yeah, might be. It's weird in a weird state. Here we go. Let's try again. Bloop. Whoop. I think we have the right mapping. I can see like the first line is 0. First line is 0. Okay, you said 2 gamma of 2 isn't great. You know what? I will always pause before sending. Okay, so let's pause it here, and then I will just reload. So we have like complete packets sent. Now let's do some coding. Let's try 2.44. Was 2.4 a good gamma value? What do you say? I couldn't tell actually. It looks for me almost as blown out as it looks for you. There is like this gradient, but like this is all 0, and then all of a sudden, like this area, I don't see really an increase. Like on the top, I don't see an increase in brightness. If we defocus, maybe then, but let's defocus. And now we should decrement also the, no, not the exposure. Yeah, we can. Yeah, it's why I try. Let me. Yeah, we can see. I like that. That looks alright. Okay, let's keep gamma of 2.4. Gamma of 2.4. Now let's do all I activate all the colors, 2.4 for all of them, and then mapping of the whole array. I will need to pause that though. Okay, paused, and then start. Whoop. Yeah, okay, this is now RGB mapped, but you can't see R because no, it is R. R is here. There is like, okay, it's like an hue RGB cube. It's mapped to the RGB cube. Now we want a wave, but I see the problem that we losing packets here. It's not a mip map. It is mapped to to the 3D space cube. So we can now animate a wave or something. So yeah, it does clamp to 0. It clamps to 0 here, min. No, it's maxing. Yeah, but there's no minus. Yeah, it's alright. Okay, this is just the test cube. Now let's do... We can now copy it. Copy it, boom! And make it case like 2. We could cycle through all the animations. And now we will do a wave. So let's do the following. We have where's the time value? T value is here. C. Okay, let's do map cluster. This is what we need. Now we will do T value. Now we have, let's say, if I have a good idea. If okay, if const d is basically the displacement, math scene times math. We could also add, I don't know if it's better like that, x y plus t value plus t value times 3 whatever. That's d times, let's say, lava lamp is a good pointed here. So if y plus d is Let's do. Okay, let's do monocolors. Okay, if it's shorter, it's smaller than. That are V0 R, G, and B, and then if this is if that, then this. We will do a blue. This we don't need that. Yeah, we don't even need that. 255 and be good. Okay. Await. Okay. Disconnect. Here we go. Nothing. Oh, wait a second. What is going on here? What? Why is y negative a negative value? No, it's not crash. Why is it a negative value? That's weird. How did I get there? Subspace. Oh, it's not Y. It should be Z. It's wrong though. Why am I here? All right. Let's not. You know what? Start. Ouch. Ouch. Did we lose it again? Do we ever get to this here? Let's run it. Yeah, we get there. We don't get a pixel. It's broken again. Oh, come on. Why did I? Ay. I don't like turning it off and on. At some point we will get some power surge or whatever and destroy this whole thing before I even... Oh! It's all black. Why is it black though? Twitch pauses. We turn it on. Okay, maybe my computer is overwhelmed when it stalls or whatever. That was weird. It is subspace. The current is it's only 80 amps. I am. We are onto something here. It's a flux capacitor. Okay, why? Oh, it's const. I'm a moron. Yes, 80 amps. It's only 80 amps. No worries. I'm such a moron. Here we go. Like if we do that, we should be doing that. Okay, we have a wave. Oh, yes! Look at that. And the pixel losses, the packet losses, makes it even look organic. like the water, like the water is. Ah, that's cool. That's like a water effect. We can increment the speed though, but I really like. Okay, 0.3 might be a lot. I love it. I love it. That's blue, but the blue looks on camera like it is white. Okay, let me change the color a little bit. Let's make it 16. I really need to stop at some point like that and start it. This is more like the blue that nah, it's too dark. 16 is too dark. Now that looks shitty. I hate it. I hate it. Okay, let's do 64. Woo! No, I just need to push the stop animation button. Okay, this is more bluish. We can do a blue Tommy, you're like OCD. You're a heavy OCD person, very perfectionist. I guess as an engineer, it's not a bad trait. But okay, let's gamma map Z, and then we have a nice, and then invert, so 1 minus. Maybe should we increase? No, we don't increase that. And then we do else will be basically the sky, which we start with green will be always, no, green will be gamma mapped Z inverted. Oh no, we should not do that. Z plus 0.1 because it gets darker the deeper we go, and this will get brighter the higher we go. And then we will do red will be always to like 128, okay? This will be that. Now we stop first, reload, and start the animation. Oh, the blue is too dark. That looks like a sunset, but it's quite bright. Oh, that looks cool. I like it. I might like it more if we get slightly more. If we see, we can increase. Yeah, 80s. We can print like text. I love it. Okay, let me stop that and let's add we can add up to 4 to blue because I like the blue a little bit brighter, and we can do the 64 and we can do 1 minus, I would 0.5 times 0.5. Crazy good color. If it's basically the SPI doesn't catch up with the USB speed, and then we get like we have like a ring buffer, and the ring buffer overrides packets. That's all. I don't think there is a problem. No, it's not physical. It's all intentional. Yeah, it's too dark now. Blue is too bright, and the yellow, I don't like the yellow. I liked it more when it was like fully. It's too dark. Start that. Yeah. That's cool. Haha! Amazing. I love it. It's a little bit slow. We need faster update rate, but the streams comes to an end, my friends. We are streaming already for 3.5 hours, and I like what I see. I will increase the frame rate or the speed. You know what? I could try. No, I can't. You know what? I will update the SPI to a higher clock speed, and we will see if we can increase double the speed, and then be good. Okay? But this is only, I do it only once. I will try it once, and then we. Okay, here. That should be easy. Actually, it's like a matter just of the first level, because like if we look. Hey, Yumbo. So if we look at our model here, we have like already this is the bottleneck right now, is like so this here might be the bottleneck right now. So if we just double this speed to 16 megabits, then it's already split to 2, and since I'm always alternating between all the levels, so I think, wait, let me check. 80. Yes, we are alternating the levels, like the highest level is like in a loop, so we always switching the SPI to a different node, so the other one has a double the time to forward the packet. So we only need to update this SPI, the level 4 SPI, and see if it helps like sending stuff. So let's do that. We only need to SPI host and then change one value. This here, prescaler to 4. Yeah, let's try it. Okay, I will update that as yeah, let's try if that works. That's a quick one, huh? Done. Okay, now it only has to work, okay? It only has to work. Let's reconnect. Well, what? Better. Oh, the SPI works at 16 megabits. We have still some lost packets there. It's probably on the layer below, and we could update these layers below as well. Yeah, yeah. What the fuck? What? That's unbelievable. What? What the this is unbelievable. You know what? Look at this shit here. So this bus here, this SPI bus, like this crappy SPI bus here. Ah, you can see that. Okay, this crappy SPI bus here, this one. Okay, this is alright, but it has to travel. It travels like half a kilometer. Okay, it's half a meter over to this, and it can do 16 megabits without issues. What? Crazy. Okay, yeah, if that one, and I didn't even like impedance match it. It's like badly routed and everything. So we can go higher on the other levels as well, most probably. I just need to be sure that I'm not doing crap there. It can be received in the next building, yeah. It's a transmission. Should we increase the speed of the time value? Let's increase the time increment or the animation speed. So times 9. Yeah. Not first layout guide. Yeah, no. I don't mind. I don't mind that you wouldn't pick me. I wouldn't pick me either. I mean, I'm not an electrical engineer and still having fun here. Oh shit! I messed up. I didn't stop it first. Now our. Okay, you know what? I can just. I'm shitty. I'm just resetting the MCU like that just by reprogramming it. Okay. Let's reload and start animation. Now it's wild. It's going wild, peeps. It's going wild. Hello. Yeah, no, we see some lost packets, but all right. I'm happy with what we see here. Seasick. Yeah, I'm done as well. Particle simulation. We are at heavy sea. Seasick. Oh no. Okay, what makes me seasick if you watched it? Oh, I'm sorry if you're watching that on VR headset. I noticed whenever there's movement back in a simulation like on VR, I get seasick. So if there is like a really weird, really weird movement back, like with the view, like I am falling back or whatever, I am instantly getting seasick. I thought I'm like, oh, I'm Mr. VR, I never get seasick or whatever on a boat and whatnot, and now I get like instant seasick if I see stuff like that. Anyways, peeps, it was an amazing stream. We did like nice demo stuff here. Just switched the SPI to a higher speed, and that's it. I will do it also to the next levels. That should cover us for better update rate. Probably remove some of the errors there. Fluid WASD movement. Oh, okay. Yeah, I had also great fun. Bye bye everyone. Have a good night.